All right, today we're going to solve quadratics by finding square roots. I'm not going to factor any today, just finding square roots. So first thing we're going to do is we're going to review the square roots, and hopefully you know how to do some of this stuff. So we'll see right here. Okay, a few words. First of all, a radical. And the radical is just a square root sign, that symbol right there. That's the radical. The radicand is the number inside the radical. The index is the number, even though it's not written there, it's a 2. It's because it's a square root. If it was a 3, that would be the index, but the index is a little number right there that tells you what kind of root it is. So radical is the sign, radicand is the number, index is the little number. Properties of square roots. You're allowed to, two things here. You're allowed to multiply 2 square roots and get a bigger one. You're also allowed to break down one big square root using multiplication, which is the more common use. Quotient property. If you have a fraction inside a radical, you can break it up into 2 different pieces and take the square root of each one. And that also works both ways. If you have 2 radicals, you can make it one big radical if the index is the same. All right, so the first thing I'm going to have you do today is simplify square roots. So what I'm going to do, they're going to give you a square root of like square root of 80 and ask you to simplify. So what I'm trying to think of here are perfect squares. The largest perfect square I can think of that goes into 80, and you're more than welcome to use your calculator to try to figure out one number that goes into 80 that's a perfect square. I came up with 16 times 5. And because I know the square root of 16 is 4, I can pull the 4 out. I have no idea what the square root of 5 is. I can't break it down at all except for 5 and 1, which does not help. So I just leave it there, and my answer, we will call that 4 on the square root of 5, or 4 on 5. And number 2, you've got a couple options here on what to do for 2. You can go ahead and multiply those and get a really big number. I think 6 times 21 is 126. That doesn't really help a whole lot. So what I like to do with them sometimes is, even though a number that has a square root doesn't go into them, sometimes they have a common factor, like 21 is 3 times 7, and 6 is 2 times 3. That's what that gives me right here in the middle. It gives me a 3, square root of 3, and square root of 3. Now, if you multiply square root of 3 times square root of 3, you get square root of 9, which is just 3. So anytime you see 2 square roots that are multiplied like that, and they have the same number, the same radicand, there's a word for you, you can take it out. So I can take the 3 out. What that leaves me then is the square root of 2 and square root of 7. You can multiply those together and get square root of 14. And 14 will not break down. There's nothing you can take out of 14 that has a square root. So you're done. Okay, there's some fractions. I told you earlier, fractions inside, you can break them down into 2. Oops, didn't mean to do that. Getting ahead of myself. You can break them down into 2 pieces like that, and then just take the square root. The square root of 4 is 2. The square root of 81 is 9. All you got to do. Same thing on the next one. Have square root of 7 over the square root of 16. I do not have a clue what the square root of 7 is, so I'm just going to leave that in there. I do know the square root of 16 is 4, and that's perfectly fine. And one thing before we go to the next slide, it's a good thing those both worked out like they did, because you are never allowed to leave a radical in your denominator. Like when I started working through, there's a radical there and a radical there. I was getting a little worried, but because they had square roots, I was fine. Never leave a radical in your denominator. Okay, so for example, this one, if I break this up into 2 pieces, I get square root of 5 over square root of 2. Now I can't break down 2, but you also cannot leave a radical down there. So what I'm going to do is called rationalizing, and I'm going to multiply the numerator and denominator by square root of 2. And that's legal because the square root of 2 over square root of 2 is really just 1. And if I multiply something by 1, I'm not changing the value at all. I'm just going to make it look a little different. So the top, my numerator, is going to be square root of 10 when I multiply. My denominator, there it is again. I got square root of 2, square root of 2. Remember, that gives me square root of 4, which is really just 2. And that's legal. And I'm thinking about square root of 10. Make sure it won't simplify any, and it won't. The only thing that goes into 10 is 2 and 5. Neither one of those has a square root. So that's all you can do there. There's your answer. Never leave a radical in your denominator. Now the next one's a little tougher because there's 2 numbers in your denominator. So if I just multiplied like I did last time, if I were to do this right here and do square root of 2 over square root of 2, I would get this in my numerator. My denominator, I would have to distribute, so I get that, and I still have a radical down there, so that won't work. So what you have to do is got to come up with something else, and we're going to do something called, it's still rationalizing, but we're going to multiply by the conjugate of 7 plus the square root of 2. We'll talk more about conjugates tomorrow, but a conjugate is just basically the same numbers with a different sign in the middle. So 7 plus the square root of 2, 7 minus the square root of 2. All right, now, In my numerator, I'm just going to distribute the 3. 3 times 7, 3 times the square root of 2, and leave it just like that. In my denominator, when you have conjugates, they're so much easier to multiply than regular binomials, because with regular binomials, I'll be doing FOIL right here. But with conjugates, you can just get away with FL, just foo. So what I'm going to do, I'm going to do first, 7 times 7 is 49. I'm going to do last, square root of 2 times negative square root of 2. You can just pull the 2 out, negative 2. And that gives me this, 21 minus 3 on 2. And on the bottom, or denominator, I have 47. Now, let me go back here just a second. The reason you can do that instead of FOIL, look at the outer inner here. If I look at just the outer inner, if I did this, that's the outer, that'd be negative 7 on 2. And if I did these two, which are the inner, that'd be positive 7 on 2. And they would just cancel each other, which makes it great because we want them to cancel. We want all the radicals to cancel so we can just get an integer in your denominator. So pretty good deal right there. All right, last thing today, they're going to have you solve some equations. And what we're going to do is we're going to use a square root. That's what the title was today. But we're going to isolate. We're going to move everything over except for the square. So first thing I'm doing is I'm moving the 5, which is going to make this side 36. Next step, divide by the 3, which gives me x squared is 12. And my last step, I have to get rid of the exponent, the 2. So I'm going to take the square root of both sides. And when I do that, this side becomes x. Now, one thing about taking the square root in an equation, whenever you take a square root in an equation, you must put a plus or minus in front of the other side. So I'm going to take 12 and I'm going to break it down. 12, just thinking out loud here, is square root of 4 times square root of 3. I know the square root of 4 is 2, so I'm going to pull out the 2. I do not know the square root of 3. It stays in. And guys, that's it. Plus or minus 2 on the square root of 3. Don't forget your plus or minus. Don't forget to simplify your radical. Okay, one more. Last one. This one's a little different because it's got a fraction, plus it's got a parentheses with a square. What I'm going to do is I'm going to make the fraction go away first like we have earlier in the year. A fraction bar means divide, so I'm going to do the opposite. I'm going to multiply both sides by 5 first. And what happens over here, it just cancels. So I get the x plus 3 squared, and over here I have 35. All right, now, almost there. I need to take the square root of both sides right here to get rid of the square. I can't move the 3 because it's squared, so I'm going to take the square root of each side. And what happens is the square goes away. Over here I have plus or minus. Don't forget your plus or minus. The square root of 35. And 35, the only thing I can think of that goes into 35 is 5 and 7. And neither one of those has a square root. So I'm stuck with the 35. But I don't have x isolated yet, or x by itself. So I'm going to take the 3 to the other side. It becomes negative 3 plus or minus the square root of 35. And that's it. And that's the main goal today, is get to where we can solve equations with squares in them, and also break down those square roots when we need to. So hope it wasn't too bad. If it was, we'll work on it some more tomorrow like we always do. I'll see you then. Look forward to it. See ya.